In this problem, we want to determine the components of the force at pin C, which is right up here. So, again, this is a frame. It consists of members that have more than two forces, multi-force members. So the way to do this is to break it up into pieces. So we're going to start by looking at member AC, okay, where I've got a pin here at A, and a pin at C, and then a force, the tension, which is the same tension up here, of 50 pounds acting straight up. Okay, now notice that it is not at the center of the beam. It is actually 0.5 off, so I have 3.5 and 4.5 rather than right at 4 on this. Okay, so what I'm going to do is I'm interested in C. I don't really care about A. Okay, I have 4 unknowns. Okay, I'm only going to get 3 equations, but I'm going to choose my equations wisely. I'm going to start with the moment about A. That leaves the pin CX and CY showing up here. So I sum the moments about A, and I get -8 times CY, okay, and then I get +6 times CX, right? The vertical 6 times CX, the horizontal 8 times CY. And then the horizontal 3.5 times 50. Okay, and again that 3.5 because again rather than 4 over, it's 4 minus a half for the radius of the pulley that I have here. Now that's one equation with 2 unknowns. So I'm going to draw the other member here, which I have here. I'm drawing member BC that includes the pulley. Okay, so I've got 50 pounds. Here, I've got 50 pounds here. Okay, so I've got 50 pounds going in both directions. I have a pin at B, and I have the same pin at C. And from Newton's third law, I have to flip the arrows. Up here, I said down and to the left. So here, I have to say up and to the right. Again, I'm using the Newton's third law that every action has an equal and opposite reaction. So forces on one are equal and opposite to the forces on the other. Okay. Now again, I don't care about the forces at B. I only care about the forces at C. So I'm going to sum the moments about B here to get rid of these 2 forces, and I'm just going to have CY because again CX also goes through point B. All right. So I'm going to have these 2 50s. Okay. One's 3.5 away, negative. One is 1.5 plus half, so it's 2 up, negative times 50. Then I have CY over here all the way 8 feet over times CY. So here's an equation with just CY, and I can solve for that, plug it up into this equation, and solve for CX, and I get the values of that. So again, when I have frames which consist of multi-force members, I break them up into pieces and apply my equilibrium equations at the pieces in order to get enough equations to solve for the desired unknowns that I'm looking for.